In this video, you will learn to simplify products and quotients of binomials that contain radicals. Now, a lot of math lingo in the objective, but products means you're multiplying, quotients means you're dividing, and binomials means you have two terms. So before we get into multiplying and dividing radicals with two terms, what I need to do is just briefly review with you how to multiply binomials without radicals. So for example, here we have 2x plus 3 times x plus 5. Now we've learned how to multiply this, where we are basically just distributing, but doing it multiple times. So here we take the 2x times the x to get 2x squared, 2x times the 5 to get 10x. And then do the same thing again with the 3. We have 3 times x to get the 3x, and 3 times 5 to get 15. And then combine like terms, 10x plus 3x gives me 13x. Now we've learned how to do that before, and this lesson we're doing the same thing, just now with radicals. So here we see the square root of 5 plus 2, and the whole thing is being squared. Now remember, when I square something, what it means is that I'm multiplying something by itself. So what I have is the square root of 5 plus 2 times the square root of 5 plus 2. And now when I multiply, I do the same thing that I just did, but in this case we have radicals instead. So we distribute multiple times. So we take the square root of 5 times the square root of 5. When you do that, you get the square root of 5 times 5, which would just be 5. The square root of 5 times 2 would give you 2 square root of 5. 2 times the square root of 5 would give you another 2 square root of 5. And then 2 times 2 would give me 4. So then what I can do is combine like terms. 2 square root of 5 plus the 2 square root of 5 would give me 4 square roots of 5. And then the 5 plus the 4 would give me 9. So what I have is 9 plus 4 times the square root of 5. Now here's another example, where once again we are squaring, which means I'm going to multiply it by itself. And now when I multiply, I take the first term, multiply it by 3 squared of 11, then multiply that by negative square root of 10. So when I multiply the first term, 3 squared of 11 times 3 times the square root of 11, 3 times 3 gives me 9. The square root of 11 times the square root of 11 will get rid of the radical sign, and I'm left with just an 11. So I have 9 times 11, which would just be 99. And then 3 squared of 11 times negative 10 would give you a negative 3. The 3 stays by itself, and you can combine the radicals, square root of 11 times the square root of 10, to get square root of 11 times 10, which would be 110. And then do the same thing with negative square root of 10. I can distribute to both terms. So negative square root of 10 times 3 square root of 11 would be a negative 3 square root of 110. And then negative square root of 10 times the negative square root of 10. Negative times negative gives me a positive. Square root of 10 times the square root of 10 would just become a 10. So what I have is this right here. And now I can combine like terms. Here we have 99 and then plus 10. Those can combine. And then these two terms have like radicals, so I can combine those as well. So 99 plus 10 gives me 109. Negative 3 square root of 110 minus another 3 square root of 110 would give you a negative 6 square root of 110. And that is my solution. Now we're going to look at multiplying along with fractions. So when you have a fraction, something like this, remember what you can do is you can multiply the numerators together, and then you can multiply the denominators together, so 3 times 3. So what I have is going to be this. 3 times 3 gives me 9, and then 2 square root of 7 times 2 square root of 7. 2 times 2 is 4. Square root of 7 times the square root of 7 gives me a 7. 2 square root of 7 times a negative 1 gives you a negative 2 square root of 7. 1 times 2 square root of 7 would give you a positive 2 square root of 7. And 1 times a negative 1 would give you negative 1. So now we can combine our like terms. Here we have 28 minus 1, and then negative 2 square root of 7 plus 2 square root of 7 would cancel. So I have 28 minus 1, which is 27, over 9, which gives me 3. Now I want to discuss a term called the conjugate, because this will be used to simplify radicals of a certain kind. So conjugate, all that means is if you're given x minus 5, so it's two terms, then the conjugate would be changing the sign that connects the two terms. So the conjugate of x minus 5 would be x plus 5. The conjugate of 2x plus 5 would give you 2x minus 5. Notice I'm just changing the sign that's connecting the two terms. So with radicals, if we had the square root of 5 minus 4, the conjugate would be the square root of 5 plus 4. And if you had the square root of 8 minus the square root of 3, the conjugate would be the square root of 8 plus the square root of 3. Now notice in this next example, if we take a binomial and multiply it by the conjugate, let's see what happens. Well, when you multiply, you have 5 times 5, which gives you 25. 5 times negative square root of 2 would give you a negative 5 times square root of 2. And then square root of 2 times 5 gives you a 5 times square root of 2. And then the square root of 2 times a negative square root of 2 would give you a negative. And square root of 2 times the square root of 2 would be the square root of 4, which would be 2. Now notice these two terms right here. Those can combine, and those would actually cancel each other. You have one negative, one positive, and they'd cancel. 25 minus 2 would give you 23. So my solution to this would be 23. But notice how we started with radicals, but when you multiply by the conjugate, these radicals right here will cancel. So what we want to use this for is an example like this, where, remember, we are not supposed to have radicals in the denominator. So we need to somehow get rid of this radical down here, the square root of 5. Well, it's not as straightforward as the other previous examples where it was just one term, because if it was just the square root of 5 down there, you would multiply the top and the bottom just by the square root of 5. But now, to get rid of the radical, because we have a binomial, what I need to do is use the fact that if I multiply by the conjugate, the radical will be gone. So looking at the denominator, I'm going to multiply by the conjugate, which would be 3 plus the square root of 5. And I do that for the top and the bottom, because what I'm really doing is multiplying by 1 in a fancy way. Because this expression right here would be equal to 1, because you have something divided by itself. Whether it's 4 divided by 4 or this divided by itself, doesn't matter what you're dividing. If you divide the same thing on the top and the bottom, then it's going to equal 1. And when you multiply by 1, it does not change your value. So what I'm doing is legal. I'm just changing the way that it looks. And for the numerator, we have 3 times 3. We have to distribute. We get 9. 3 times square root of 5 would give you 3 square root of 5. And then square root of 5 times 3 would give you another 3 times the square root of 5. And the square root of 5 times the square root of 5 would give you square root of 25, which would just be 5. And then the denominator, you would have 3 times 3 gives you 9. 3 times square root of 5 gives you a 3 square root of 5. Negative square root of 5 times 3 gives you a negative 3 square root of 5. And negative square root of 5 times a positive square root of 5 would give you a negative square root of 25, which would just be 5. So notice, now we have this, and 3 square root of 5 minus 3 square root of 5 will cancel. And 9 minus 5 would give you 4. 9 plus 5 up here gives you 14. You can combine these as well to get 6 square root of 5. So what I have for the numerator is 14 plus 6 square root of 5 over the 9 minus 5 is 4. Notice the radical is gone in the denominator, which is what I wanted. But one last thing, notice that each part of this fraction can be divided by 2. So I can divide everything by 2, and I would get, divide by 2, I get 7. Divide this by 2, I get 3. So I have 7 plus 3 square root of 5 over 2 as my solution. And that concludes our lesson for today. We will see you next time.